Hello everyone, my name is Vivek Panicker. I'm working as a software developer at Inorak for the last 5 years. So first of all, I would like to thank you all for giving me the opportunity to speak here. The topic of the presentation is caching in Drupal. So I'm going to explain about the caching features which are provided by Drupal 8 and 9 basically. So first, in the beginning, we'll see the theoretical stuff followed by some practical demo in the end. So first, just to go quickly over why we need caching. So what is caching basically? Suppose we have some data which takes a huge amount of processing power or like time to compute. It is not feasible to do that on every page request that happens. So we use some fast memory which can store that computed data, and this data can be used the next time directly without going to the backend to compute the data again. This increases the response time and saves server resources, because again that tedious computation doesn't have to be done again and again. So we are saving server processing power, server memory and everything. And in the end, we are saving money, because with the increasing server usage, we are getting billed more. So if we reduce that processing, and if we reduce the time taken, then and we just directly respond from that cache, so that indeed saves us a lot of money. So there's a very famous quote which is there when we learn about caching. So there are two hard things in computer science. One is cache invalidation and the other is naming things. So naming things means like naming variables and everything, or functions. And the other is cache invalidation. So you've cached something, means you have computed something, then you have stored it in cache. That's good. But now you have to invalidate that cache, or you have to mark that cache stale when the data source has been updated, or when the thing that was computed, that thing has got updated. You need to invalidate this cache. So these were some of major problems which were faced in earlier versions of Drupal till Drupal 7. And Drupal 8 has brought about some very big changes in this aspect. So that is what we are going to look over here. First of all, where is the cache stored? We'll start with looking at that thing. So the storage location, the actual physical storage location where the cache data is stored, that is called the cache backend. Out of the box, Drupal stores almost all the cache in the database. We'll look at that later in the practical demo, how it is storing in the database. So basically there are different tables where this cache data is stored, specific tables which are allotted for cache data. Now, out of the box, we get the database cache backend, but later on, if we want to configure a different backend, for example, if we want to use memcache to increase, because memcache is a very good caching solution, so we can configure that also to work with Drupal. So basically, there's a contrib module which is available. We need to install that and make a couple of line changes in settings.php file to point to the memcache and to mark like which cache backends will be using memcache. So we can individually configure like, okay, cache, this particular cache should use memcache, this particular cache should use database, this particular cache should use Redis or something like that. So that's completely in our hand. Drupal provides us this feature. So so apart from database backend, Drupal core is also providing these other backends like PHP backend, memory backend, null backend, chain fast backend. So null backend you might have seen when you have started with your development work. So basically, in order to disable caching, we usually use the cache.backend.null service to disable caching. We'll look over these things later on. And chain fast backend, this is the most important, most amazing thing, because it allows us to group together two cache backends. So one cache backend might be fast, like an in-memory cache, and behind that there will be a slower backend, which might be the database cache. So we can combine both these things together and form a single cache backend. So that is what chained fast backend is about. So we can chain two backend systems for cache and use it in Drupal. So the next thing is cache bin. So what are cache bins? So basically cache backend, this was the physical storage space for cache data, and cache bin is like logically partitioning the cache data. So we might have several different types of data that we want to cache. For example, if there's a e-commerce website, we might want to cache product data, we might want to cache stock data, orders data, and stuff like that. So it is not very convenient to cache all of them together in one particular location. So what is the reason? Like suppose we consider the database being used as a cache, and if we store all the data for order, products and other stuff into one particular table, and if our site is very active, so in a very short amount of time we'll find that the table has become so huge, it's like gigabytes of size, and that makes it difficult for the database server to even find something from that table, because if there are thousands of rows, then the server has to find that particular cached item, and that retrieval will take a very long amount of time. Thus, like the purpose of caching is lost basically. So we are caching so that we can retrieve data faster, but if we like store everything into a particular table, then this retrieval becomes slow, so that becomes like anti-logic to the thing. So that is why we use this cache bin. So we can say like, okay, this particular piece of data would go to this particular cache location, which is basically a logical partition of cache. So for product we can have a product cache, for order we can have a order cache. So it becomes we can understand that the each of those tables would be smaller in size compared to a single table containing every one of those things, and searching for anything would be faster in that. So that's the, and it like also helps to debug stuff, because later on if you might are facing some issues related to caching and you are trying to debug things, so it'll be easier, like, okay, you know that there's a problem with caching of products, so you can easily look into the table that stores the cached product data. So you know where to find that thing. So out of the box, Drupal has already provided several cache bins, which it uses mainly for its purpose, and which is also like usable for our purpose also, developers' purpose. So these are the Bootstrap cache. We store some information that is needed to start Drupal. So every time Drupal starts, there's a very complex computation that happens. And if a lot of those computations are cached, then the Drupal load time would be slower. So that is what this cache Bootstrap is about. Then we have the config cache for storing configuration information, container cache for storing information about services. So that is why if you have seen that if you are ever defining a service, then you would need to clear the cache, because this container is rebuilt and it is basically cached in the database. The service container is rebuilt and cached in the database, so that it doesn't always need to like scan all the modules and then fetch the services and then store it and then you make it available for us. So it can simply fetch from the cache, and that would be faster. Then render cache, page cache, dynamic cache, these are basically storing rendered data. That is output. So render is like part of the output. Page and dynamic page cache are almost like the entire HTML response that would go to the front-end user. Those things are cached. So we'll again have separate discussion about them. And each of those has a separate database table. So if you want, if we want like to create some custom cache bin, we can also do it via simply writing some lines of code in the service file, services.yml file. So let's look at page level caching now. So there are two caches which provide us with the feature for page level caching. One is page cache and the other is the dynamic page cache. So page cache is basically like Drupal's built-in reverse proxy server. So the request would first go through page cache into the interior parts of Drupal. And it's also, I think, called as something as poor man's varnish, I guess, because it's already freely available. Drupal is providing it out of the box. So what does it do? This page cache, it stores the complete final rendered response. So whatever, after clearing a cache, the entire cache, we do a cache rebuild. Then we hit the Drupal website. So all the data is computed that is required to be displayed in the page. And then the final data, which the complete HTML data, that is stored in this page cache. And it is mainly used it is used actually for anonymous user caching. So it is not used for authenticated user caching. We'll see how we can achieve that later. So now again, that quote we read about, that we need to invalidate things when something gets updated. So since this page cache is storing the cache of the entire page, so suppose there's a block on the page that gets updated. So we need to make sure that when the user saves when the admin saves the block, that should immediately appear on the page. So a page cache's entry gets invalidated as soon as any of its cache tags are invalidated, which we'll see later on what is basically cache tag. So basically these things are updated instantaneously. So if something in the page changes, this cache gets invalidated and fresh entry is done after computing the fresh data. So previously in Drupal 7, what I've read is that if there is some basically some new content that is supposed to appear in a page, then the entire page cache is invalidated. Well, that is not at least the situation in Drupal 8, because only those content, only specific contents are updated, not the entire page cache is not flushed. Only those parts or only those pages which are affected by some content change, those are updated. So previously we saw the page cache, which is used for caching anonymous user data, but what about authenticated users? So a site can also have many authenticated users. For example, any shopping website, it has we can log in and make purchases and stuff. So there should be some amount of caching for authenticated users also. Otherwise, what would happen is that every time an authenticated user visits a page, that entire page will be rebuilt from scratch, and thus increasing our server load by a huge amount of time. So that is where Drupal 8 provides this feature of dynamic page cache. Dynamic in the sense that it considers that there can be some parts of the page that are dynamic. So as authenticated users, they have a lot of personalized content. Those parts of the page which display these personalized content are replaced with placeholders. So there might be so let's consider the home page. So there might be a section which shows hello Vivek. There might be a section which shows the news feed, perhaps like in Facebook. So those things are personalized. Those are not these are different for every user. So what Drupal does is that it understands the developer needs to provide that information, and from that Drupal understands that okay, this particular page, it has some personalized content. So what it does is that those personalized stuff, it doesn't put into the cache. Instead, what it does, that instead of those stuff, it puts some placeholder for them. So this is a process which is called auto placeholdering. So it puts the placeholder into the entire page along with the placeholders into the cache, and before rendering the page, it will replace those placeholders with the actual content that needs to be displayed. So this offers some improvement over no caching at all. So as some parts of the page are at least cached. So yeah, means this is useful in that respect. So this is kind of a diagram which was uploaded by Wim Leers. So he's one of the members who worked in this feature basically of introducing page caching and dynamic page caching. So we see that here we see a render array. So this is like maybe a block or maybe a controller which is returning some array which is to be shown on a particular page. So that controller will return an array, and from that we'll form some fragments. So this might be a block, this might be a link and other stuff. And the red stuff you see are basically the dynamic content. So this particular block this particular region might have some dynamic content. So that is what is being shown here. So first we'll start from here. So basically the request goes from here. Suppose there is nothing which is cached, so it will go directly to the controller or to the block, whatever it is, and that will provide the render array. That render array will pass through the renderer, which will generate some HTML fragments. That HTML fragments might contain, some of those are like not personalized, some of those are common for all kinds of users, while some of those fragments, they might be personalized, and that is depicted by the red color here. Now these fragments, aggregated fragments, are then aggregated to form a partial HTML response which contains this. So this is practically the entire page with some dynamic content that is supposed to appear. So this red part is actually the placeholders. So we are not preparing them right now, because if we prepare them right now, then that would mean we are caching a huge amount of things for each and every user. So instead of that, what we are doing is that we are putting some placeholders for the personalized part and leaving it like this in the dynamic page cache. Now, if the request had come from an anonymous user, this would straight away the anonymous user, basically the content is the personalized content would be the same for all anonymous user. There's nothing personalized about it. So this, from this dynamic page cache, we would fetch and put it into the page cache after replacing the placeholders, which would be common for all anonymous users, and then we'll directly show it to the user. The other thing is that authenticated users might access the page. So for them, we'll fetch from the dynamic page cache, and we'll replace those placeholders, and then we'll send it to the authenticated user. So every time the authenticated user, say 10 times he visits the same page, he refreshes the same page. So the first time a request would go completely to the back, and then from there we'll gradually proceed and store it in the dynamic page cache. And after that we'll replace the placeholders and send it to the authenticated user. The next time again the authenticated user hits the same page, so we won't go directly into the controller which provides the response. We'll just start from here, and then we'll replace the placeholders and send it back to the user. So there's also a new feature that is called Big Pipe, which works very well with dynamic page cache. So basically we return directly this partial response without replacing the placeholders directly to the browser. Then from the browser, there is a TCP connection which is kept open with the server, and we constantly, the browser communicates with the server to get the response for the placeholder basically. So this has an advantage that the dynamic page cache is a bit slow because it would have to compute the placeholders and then provide the response to the user. But if you use Big Pipe, we send the response to the user first, and then we continuously, the server keeps streaming the placeholder data to the browser. So the page load time would increase if we use Big Pipe. Yeah. So that is all about this page cache level thing. Next, looking at the cache API. So Drupal allows us developers to provide our own cacheability metadata, which means that basically the thing that we want to cache, what are the stuff that it depends upon, how often does it change, and on what conditions that it change. So we are able to mention each and every one of those things so that Drupal can properly cache those things. So let's look at those things. So starting with the cache API, so it there are basically three things that is offered by the cache API, which is cache tags, context, and max age. So these are a bit important things. I was very confused initially when I started with development, but in course of time, while working on different scenarios, I gradually understood these things better. So it's very important also to understand these things so that a lot of problems can be avoided basically in production. So what are cache tags? The data that we want to cache. So is it aggregated from some other sources? So is it dependent on some other sources of information? So if yes, then we need to specify those dependencies when we are generating the render array, so that in case any of the data sources that changes in value, then our cached entity should also be marked as stale, and a fresh cache entity should be generated based on the updated values. So these dependencies, the way of providing these dependencies is in the form of cache tags. So cache tags are nothing but an array of strings which look like this. So in this format, thing : identifier. So it's an array. So we can specify multiple cache tags based on what dependencies are there. So the thing value can be anything from node, config, user, taxonomy term, and the identifier is basically the ID. So node ID or config name or the user ID or the taxonomy term ID. So that's how we specify cache tags. Recently, some list cache tags have also been added, which means that, for example, a view is showing a list of information. So if we are showing, say, recent articles view, so we should provide the node list cache tag to that recent articles view. That is because whenever a new article is added, the view should get updated automatically. We should not have to clear our cache to update the view. So if we provide the node list cache tag to the view, what happens is that the node list cache tag gets invalidated whenever a new node is added or an existing node is removed. So basically, when the list of nodes changes, this cache tag automatically gets invalidated. And because a view also contains this cache tag, that would also get invalidated and a fresh view would be generated. So that's the importance of cache tag, basically providing any data dependencies that are there for the cached entity. So example, if the cache data depends on the data of node 5 and the system.site configuration, we have to specify cache tags in the following way. So in the render array of the controller or in the block or something, we have to provide these cache tags. So there are dynamic methods for fetching the cache tags, which we'll discuss later in the demo. Cache tags, important point to note is that cache tags are invalidated across all bins. So initially we had seen that cache, we can separate cache into separate bins. Drupal also out of the box provides separate bins which we can use. And if any of this cache tag, say this node 5 cache tag is invalidated, then it is all the cached entities which are present in the different bins, all of those are invalidated. It's not that a particular bin is considered, all the bins cache tags gets invalidated. The CDN support using cache tags. So Fastly, Cloudflare, they currently support using cache tags. So that makes it a much better experience for the basically site administrators, because they are able to instantly see updates even while using the CDNs. So the problem with CDNs is that we may sometimes specify that, okay, data should be like cached in the CDN for 20 minutes or 30 minutes. So there's a 20 to 30 minutes lag between the content being updated on the server and the content being reflected on the end user side. So that thing can now be bypassed by using this because the CDNs now support using cache tags. So CDNs like Fastly, Cloudflare, there is a module for Cloudflare which is available in Drupal. So basically, I think installing and configuring that would automatically purge the cache tags, send the cache tags which have been invalidated in Drupal into Cloudflare, and Cloudflare then would take care of invalidating those cached entities which have those cache tags. So we don't have to manually go to any URL and purge the URLs, or we don't have to manually clear the entire Cloudflare cache or anything like that. So Varnish is a similar thing on the server side, and it supports cache tag. Control module like purge can be used to flush the cache tags. So Cloudflare purge is there, and purge module in general is there, which has several sub-modules which connects with other systems to purge the cache. So we can use that for our purpose. So next we come to the point of cache context. So now we can invalidate the cache because of the cache tags, but what about having different representations of the cache data? So for example, there is a block which shows the username. So that block would have different representations for different user, because for every user it would be showing that individual username. So that is a context. So like the user is a context on the basis of which the cached entity changes in value. So these are basically called cache context. Or for example, you can consider a node page. So if you have a multilingual site, your node page should be available in different languages. So basically there we can provide the cache context of language, so that on the basis of language our cached entity can vary. So how can we provide the cache context? Again, as part of the render array, we can provide the cache context. So whether it will be changing by URL in an array, we can specify whether the cached entity, it will be changing with every change of the URL. Will it be changing with every change of the language, or will it be changing with every user? That we can provide in an array format to the cached entity as a cache metadata. Each variation, so it's not that there is a single cache which is there. So each of those variation, like for if there's a block showing the username, so there'll be like one entry for a block showing username 1, another entry for a block showing username 2, another entry for a block showing username 3. So there are multiple entries for every user. Multiple entries for multiple users. So yeah, that's the point of this cache context. And finally, we come to cache maxage. So basically, we don't use this feature much because Drupal is already providing us with this cache tags and cache context thing. But even if you want to discuss about this, so is there any for the cached entity, is there any specific time period after which it should get invalidated? If the answer is yes, then we can use the maxage, cache maxage feature. Maxage 0, that value signifies that the entity should not be cached at all. It is completely uncacheable. So Drupal doesn't cache it, and every time it will compute that data. So every time it will go back to this render array and compute the data for that particular entity. And any point to note is that at present there are some issues with maxage equal to 0 being set for anonymous user content. So we should be careful when using that for anonymous users. So there's the concept of bubbleability of cache data. So what this means is that from the smallest parts of the page, the cache data, it gets bloated to the entire page. So suppose I have a small link, or maybe suppose a block on a page, and there are maybe hundreds of blocks on the page, just saying. So the entire page should actually know that what is the cacheability metadata of each of its blocks or each of its contents, basically elements. And because the page cache, it needs to get invalidated, so it won't get invalidated if it doesn't know like what are the contents that I am displaying. So that is why the cache metadata from the smallest parts of the page, for example a block, that will appear as the cache metadata for the entire page. So if we have created a block and mentioned that the block has a user cache context, or it has a user:3 cache tag, we'll see in the final output of the page that the entire page in fact has the same cache tags, includes the cache tags of that particular block. So then only will cache invalidation work properly. So it's just to give an example which I thought of myself. So like a bottle of soda, when we see that there are small bubbles on the bottom and it just rises up and to the surface, it then disrupts the entire surface of the soda. So that way, whatever cache metadata we provide for the smallest part of the page, that one becomes the part of the cache metadata of the entire page. So cache tags, context, maxage, everything bubbles up to the page cache level. So now, how can we know that what are the cached tags or contexts that are there for the page? So for that we want to debug some scenario, and for that we can, in our services.yml file, we basically need to enable response headers debugging, which I'll show in the demo. And after doing that, we start receiving these cache tags, x-tuple cache tags and x-tuple cache context headers in the response, so we can see them in the network tab, and it is very useful for debugging. So we should use this with caution, because incorrect usage, so the entire cache metadata that we are providing as a developer, we should use it with caution. Otherwise, there is a possibility that if we are providing wrong cache metadata, that can lead to some potential security issues, because we end up showing content to users that is not a particular user, maybe that belongs to other user, and we are showing that content. So we are only supposed to show content for that particular user, but instead we end up showing it of somebody else's, then that's a security issue. So Cache API provides extension for custom usage. We can easily create cache context, cache tags and use it. So that's a very awesome thing that Drupal provides. Memcache, for example, provides its own cache backend, so we can see that from the Memcache documentation. Okay, so that's all part of the presentation. So I'll quickly jump over to the demo.
Any questions for Vivek?
Yeah, I have one question regarding page cache. So, as you mentioned, if we have a cache tag with something, single block is showing over the page, and if we invalidate the block tags, and that content will be displayed over the page.
Yeah.
So, how page will know? Will that invalidate all the page tags, or just for that particular block? I mean to say, the caching will be attached with the UL itself. How the page will know to invalidate? Is it a complete page invalidate itself if a single block invalidate the tags, basically?
Okay, so I can show you the concept behind that. So it's not that Drupal will manually go and invalidate. So suppose a block has say a block is displaying username, and the username got updated, and we had provided correct cache tags for the block, and the block invalidates the user cache tag. Now we are saying that the page cache would also be invalidated. So it's not that Drupal will go and invalidate each and every, like after the block content is block cache is invalidated, the it will go and invalidate every one of those page caches. Basically, what happens is that when a request will go to Drupal, it will first check whether the cache that it has is valid or not. So, like this is the database of the site which I was going to demo. So basically, you can see cache page. So this is a particular page which I loaded, and you can see the cache tags, right? So if I edit that, so these are all the cache tags. So you see user 0, user 1, you can see these cache tags which are appearing here. So what it does is that when the request comes to Drupal, it will first check this page cache. It will come here, it will check if there is any page cache available for that particular page. So this is for the home page, basically, Drupal.log. So, and that page cache is comprised of these cache tags. Now we also see this field called checksum. Now what is this checksum? Basically, it is a sum of the invalidations of all the cache tags. So there is another table called cache tags. So this particular table, what it does, it stores all the cache tags which are available and have been invalidated at least once. So unless a cache tag is invalidated, it doesn't appear in this table. But once a cache tag is invalidated, it starts appearing in this table. And then this table keeps a count of how many times that particular cache tag has got invalidated. So we can find all these cache tags in this particular in this table. So how the checksum is calculated? Basically, let us go to config log branding, search. So we see the invalidations is 1. So like this, Drupal will search each of these cache tag in this table. It will fetch what is the invalidation value for each of these cache tags. And when this page cache was created, it found that the checksum was 713. So the sum of the invalidations of all these cache tags was 713. Now this checksum is checked on every request that comes to Drupal. So the next time the user came, suppose the block cache tag was invalidated. So in that case, in this table, that particular block's cache tag would increase by invalidation would increase by 1. So say it was the branding block cache got invalidated. So now this would become 2. And does this contain branding? Yeah, it contains branding. So next time the request comes to Drupal, it will, when it computes the checksum, it will find that the final value of checksum will be 713 plus 1, because the number of invalidations of block branding has increased by 1. Now the total would be 714. So 714 is not equal to 713, and hence the cache is invalid. So then Drupal will go ignore this cache, and it will go to the actual backend completely and process everything that is required. And then when it stores data in the cache, it will become 714, because the current value is 714.
Okay, so that means we can, in other words, we can say the total page cache is invalid in that case. If single,
yeah.
Okay,
If any of these single things is invalidated, then this checksum would become incorrect when calculated with the new checksum. So Drupal would then realize, okay, this thing is invalidated, and now this entire cache is invalid. So let me fetch the complete data again, let me process it, save it, and I'll save it with the new checksum, and then I'll respond to the user.
Thank you.
Okay, so I think I have 3-4 minutes left. I can quickly take some other question if you have, or I can just show a quick demo of cache tags and contexts. Let me clear first all the caches. Now in my code, I have this particular block in my code, my custom block, and what it will do is simply return a markup, and there's a user field called field custom username, it will just simply show hi and the value of that username, and I'm not providing any cached metadata. So cached metadata is provided like this in the render array, but now I'm commented that code, and let's see what happens. So this is a admin user, super admin. Let's see what is shown. So it's showing hi super admin 1. So this is the field value, and it's showing hi super admin 1. I have logged in as another user, which is Chrome user. Now if I refresh, okay, it's showing Chrome user. Okay, let me check another user basically in Firefox. No, not this one, this is, yeah. So let me just close this to avoid confusion. So this one is also showing Chrome user. So this is a Firefox user. The custom username is Firefox 5 and it is showing Chrome user. Whereas I think super admin thing is not getting cached. That's why it's like this. So let me look at two authenticated users, not admin users. So this one is showing hi Chrome user, and this one is also showing hi Chrome user, although this one is a Firefox user and this one is a Chrome user. The reason for that is that we have not provided any cache metadata here. So actually, let me comment this one. So I was actually showing cache context. So again, the same thing with the time. So let's ignore the time value. Again, I'm showing the same thing basically, and now I'm providing the user context. So if I clear the cache once, I have to do it twice. There's some problem in the site. Yeah. So now I'm again refreshing as the Chrome user. So I can see hi Chrome user. Now I'll refresh as the Firefox user. I think there's some, there's cache problem here, I said.
Browser cache?
No, not browser cache, but something. Okay, yeah, it was, thank you. It was, I hard refreshed and it appeared like this. And let me hard refresh this. Okay. So now it's appearing fine. That's because I provided proper cache context here. I said that this particular block render array, it's going to vary based on each user. So what Drupal does in the backend is that it will cache render, select data, search, CID, like custom. So this is my block, my custom block. So that's my block. And as you see, there are two variations created, one for user 6 and one for user 7. So Chrome user is user 6, Firefox user is user 7, and there are two variations that have been created. Similarly, if we have more users, a variation for each user would be created. And if we just look at what is this particular data that is being saved, so we see the actual data which is appearing. So this is for, I downloaded for user 6 and it is showing Chrome user. So Drupal will fetch immediately from here. And so once this has been cached, Drupal will next time pick from here and show it to the user. But now let me try to change the username of the Chrome user. Let me try to change the field value. So this is the field value that is being displayed. So Chrome user now. So let me change it to now. Let me save. Okay, this is got updated. Now one. Yeah, so I saw that. Okay, let me just comment this cache context. So suppose I am not providing any cache context. So that cache context somehow seems to add the cache tags also. So I refreshed. Now I'll edit. I'll make it now 2. I'll save. Somehow it's getting updated even though I have not provided the cache tags. Okay, let's skip that part then, means as we are running out of time, I can't debug now, but let me show you some other important things. So like this, we can provide cache tags, and we don't have to like write cache tags like in the string format. Normally, I've seen many people like write like this: user then $user ID. So we don't need to do something like this. These are all values that can be fetched dynamically. So every entity like user, node, taxonomy term, they have this method called cache tags. They have methods for cache context and maxage also, which we can use to dynamically get the values of cache tags. And so this is how we specify cache tags, and we can add another key here for context. So this would be the ideal thing to provide in this block build function, that okay, it depends on the user cache tags, it depends on the user cache context. Maxage also, if you want to provide, we can provide it in this way. And final thing, like in development.services.yml, we can mention this particular key, which I mentioned earlier. Like we can add this particular key, and what this helps us is to see in the network tab. So let me go to the view page. So in the network tab, in the headers, I can see all the cache tags and the cache context that is there for this page. So we can see we added the user cache context. So that is here. We added the user cache tag. So this is user 6. So we can see the user 6 cache tag here. Similarly, if I go to Firefox, if I go to, where is it, network, I reloaded the page. So here we are able to see the cache tag. This is user 7, because the user is 7, that particular cache tag got added, and the user cache context also got added. So this is the ideal way that we should be specifying cache data, and that appears in the database also, in the page cache, in the dynamic page cache, as we have seen here. Yeah, I think that's all I would like to say right now. Yeah, I think I'll end my presentation here if anyone has any further questions.
Thank you, Vivek. This was great.
Thank you so much.
The slides so that we can share with everyone later.
Sure.